We're going to be continuing our Pytorch expert journey. We're going to be building an LSTM today. We're going to continue because this is a long one. There was a lot of customization that we've needed to do with the tutorial in our data preparation, which is a large step, part of the picture. One of the things that I was unfamiliar with is that needed for a 3D tensor when you're inputting into an LSTM layer. Let's continue on with our approach here. Let's see where we at. We left off just getting started with our LSTM. So we did all of our data prep over here. Let's keep going. I'm excited about this. Good day, you guys. Good day. It's all nice and sunny outside, and I've got my window right there. The window's closed off. I can't see outside, but there's like little peaks I can see the pretty sky. Okay. So we're going to store some of these things. We're going to store embedding dimensions and our hidden dimensions and our vocab size. Let's go ahead and store these things locally so we have them available to us. We're just going to save these things. Embedding dimensions equals embedding dimensions. We're going to copy paste these things here. We're going to make it easy on ourselves, yeah? There we go. Little bit easier right there. So that way we can store these things and have them around for a little bit later. Comments, thoughtful. Oh yeah, keep comments thoughtful. Yes, absolutely. Have a good day. Let's start coding. Yes, exactly. We'll get our coding on here. Okay. Now we're going to do vocab size. Vocab size. Boop. Okay. Equals. Get things all. I like everything aligned. So then we're going to do num classes, which is my own approach. Is I like to say number of classes. And I say number of classes because it's like the number of output targets, right? How many things are we classifying? So how many classifications? How many things are we classifying, right? How many things are we classifying? That's what that's all about there. Now we got our data there. We're also going to need an self.LSTM. I know we're going to need that. It's going to be nn.LSTM. And we need it to be embedding size. And we also need the hidden, right? I think that's LSTM right there. Did we get that right? Let's find out. Did we remember? Yeah, we sure did. Oh, we forgot the word embedding. So vocab and embedding dimension. Okay. So self embedding equals, I'll just call it embedding. Yeah, embedding. So that would be embedding. It's going to be the embedding. Vocab size. That's what it is. Vocab size, embedding dimensions. And then we've got our embedding dimensions on LSTM and then hidden dimensions. There we go. And we're going to need a self.L1 equals nn.linear. And that's going to be our hidden dimensions, comma, our num of classes. Boom! Did we do it or what? No, we figured it out. Hidden to tag. All right. We called it L1. We didn't call it hidden to tag. We called it something different. So we got our word embeddings, we got our LSTM, and we got our hidden. And I think we did it all correctly. Now let's define our forward pass here. Let's jump into our forward pass, you guys. Let's pop on over to our forward pass. All right. Def forward, self, and our inputs. We've got this memorized, you guys. We got this memorized. Although not really. Which one do we need to do first? We got to do our embeddings first, right? So this is going to be our sentence, right? Sentences. Is it multiple sentences? I think it is. All right. Out equals self dot embed sentences. Sentence, right? So, we got to spell that properly. There we go. Make sure we're spelling correctly. Yeah, I was using Gemini. Told me to. It did. Nice. Very nice. All right, you guys. We're gonna do out equals self.ls. We gotta do out, comma, underscore LSTM. And I believe it's the out. Although, wait. No. We gotta do some view changes, right? We gotta do some view changes here. We need to take the output and get the length of the sentence. And then we need to view 1 and -1. Okay. We might need to adjust this a smidgen because we might be, we'll play around with it. So that is the, let's see, embeds out, so dot view. And we're going to say length of the sentences. Although I'm feeling like maybe, we're going to find out though. 1, -1. So we're going to add, it needs to increase the number of dimensions, right? We're increasing the dimensionality. However, I don't know if we need to do this. If we are doing multiple sentences, we might not need to increase the dimensionality. It might not be something that we need to do. We're going to find out though. Yeah, we are. Yeah, we're going to find out. We sure are. Okay, so that is LSTM right there. Is that it? Yep, okay. Out equals self dot the hidden. No, this is L1. Let's see. If you want to do Android dev, go to Google Developer Android courses. Nice. They give you a free web-based course that covers everything you need. It does. That's where I learned a lot of the Android stuff myself. I like it because they've got separate segments, right? They've got like a tutorial. Let's get back to our Pytorch here. So we need to inputs prepare sequence, word to IDX, input tag score, model inputs, print score. See what the scores are before training. Oh, yeah, it's a good idea. We should try that. All right, so we've got a loss function. Triple, what is this? What is this, a triple loss? What is it? What is loss? NLLLoss. What is that? I'm curious about this. Let's learn about this real quick. What is this? Negative log likelihood loss is a useful to train classification problems. Oh, no way, really? I've never used this loss function before. If provided, the optional argument weight should be a 1D tensor assigning weight to each of the classes. Oh, this is particularly useful when you have an unbalanced training set. All right, well, we don't have an unbalanced training set. We just have a minimal training set. So let's continue on with this segment. So we're almost done with this. Let me pop back over to the tutorial. What do we miss? I know we missed something. Oh, right, we got to activate it. Okay, so we're going to use a log softmax 1 dimension. All right, let's do this. Our out equals log, I think it's nn.log. Is it functional log though? Hey, also here, hey, over there in the purple. Are we continuing with the tokenizer? Yes, we are. Yep. We got the tokenizer. We built it. We got the dictionary build here, and then we need to vectorize it. So this will be essentially the tokenizer, right? Tokenizer, right? So this is our input data, training data. This is the training data, which is going to include both the tags and the sentences. So the training features and the training labels. So let's continue with our model real quick. So log softmax, and we need to do our out, comma, dim equals 1. We're doing this from memory now, you guys. We know what's going on here. Return out. There we go. So now it's our forward pass, and we've got our model here. We've got our parameters, our layers, and our forward pass. Good to go. So we've got our layers, we've got our forward pass. Now we need to prepare our data. I think we can do our data prep now. Let's do our tokenizer, and we're going to look for all of our data, and it's going to be this training data. So we're going to inspect the features and labels to match up. So we're going to do our tags. So we pre-built our dictionary. So we've got our dictionary built right here, and then we've got our tags built. So build dictionary. What if we also do def build tags data? We've got our tags. So we're going to build our tags dynamically is what we're going to do. We're going to dynamically build our tags. All right, you told us about the difference between the AWS compute cost once. Yeah, hey, Torva, good memory. And that one interview with SB that wanted to automate that process. Whoa, Torva. That's crazy. Okay, so let's build our tags. And we need our data. So we're going to say we need, here we go. Let's do tags equals, we'll do tags like that. So we're going to dictionary and tags, our features and our labels, right? So these are features, these are labels. All right, dictionary, let's delete that real quick. Delete that. And then I want to build the tags, and let's do tag build. Build tags. We need the data though, we need the data. So let's do this down here. Let's do this down here. Where's our data at? It's over here, okay. Tokenizer, data, build that in here. We'll leave that for later. We are building an LSTM, which is going to help us with sequential data. In the docs, it says it's meant for time-oriented data. However, that's not true. It doesn't have anything to do with time. It has to do with sequence. Time's not really a factor in this case. So it's really about order of operations. right? The dog ate the apple versus apple, the ate dog, right? Apple the ate. So if you say it in a different order, it means something different. So it's all about order, sequence. So that's why we're doing an LSTM, a recurrent neural network. Recurrent neural network to our Pytorch. This is very clean assembly. This is very clean. Prod by core. Good job. Good job. Okay. Binary, not Malbogl. Yep, not the Malbogl. Hey, Malbogl mentioned. Gotta always mention that. Okay, so we've got our data here. So it's a little bit rough now. So we've got our tokenizer. We're going to basically vectorize our. We're gonna vectorize. I'm just gonna call this vectorize because it's a little bit more general. So we're gonna get our data, which is our training data. Then we need to return our. Wait. Hold on. We need to think about this for a second. So. Okay, so we already got to build. We're missing one thing. We need to build our tags. Okay. So for tag in, how do we do this? We need the second element of all of our samples is what we need. So I need to create this. So we got our we already have our tags here. So we need to updates. We'll think about this. Oh, hey, how's it going there? You sent the happy for 10 dual solo bolo clips. Well, thank you. Let me double check that if you actually did that. Go to funding is here. Yeah, hey, solo bolo clicks. Thank you for the 10 jewels. Appreciate it. It looks like a regular chat message, so it was a little difficult to see. We got to do a few things here. Let's close this. All right, so we need to tags in data 1. So here's the thing. We need to create a view on this data. We need to capture just the second elements. We want only actually, okay. For D in data, sample. For sample and data, we're going to say our tags equals the sample 1, right? So that'll be your tags. Although the problem is though, we've already defined that. We've already defined the word tags. Almost the weekend. Yay, I know wisdom nuggets, you guys. Almost the weekend. Holly jolly. Okay, so this is like a generator, right? The build tags function. It is, we're not using yield. So there's no yield in here, right? So yield, did I spell that right? So there's no yield. What we're doing is we are going to, it's kind of generator-y, but not really because we're not returning any closures or yielding anything or saving state. So this is just a regular function. This is what we're doing. This is a regular function. So we got our samples. We got our, I don't know what to call this. We'll call it, elements, rows, inputs. We'll call them inputs. Okay, we'll call them inputs. But they're really tags. They're really just tags. The thing is, it's conflicting with this, and I can't override the variable. Hey, come on, what are you programming? We are in Python, Pytorch right now. We're learning how to build with Python. I want to make sure this is going to work. La la la, updates, and we say tags.update, updates, I think, right? I think that looks good. We could also just move this all into one line, right? We can get fancy like that. Just a little bit of fancy there. Just a smidgen of fancy. And then we're going to make this a little bit cleaner. There we go. All right. Boom. The build tags function is complete. SQ, lighter. Okay. I'm pretty sure this is good. How about this? How about this? Can we do the same thing here? Let's do this. We're gonna mimic the bonus that we did here. Okay. All right, that looks good to me. We also need an offset. I believe, right? We got to get the offset going. Yes, we need the offset every time. Offset. We need to do I plus offset, right? Oh, I got this wrong direction. I always mix this direction up. I plus offset. Here we go. This is going to be tags. There you go. Tags update, tags offset, lengths, dictionary increase, enumerate tags and tags, if not tag and tag. There we go. Let's continue on with our adventure here, you guys. So I think we got all of our data prep set and go. We got our dictionary builder and we got our tag builder. We've made some corrections with our filter on our dictionary comprehension. So this part should work okay. So what I want to do is, we haven't defined our vectorizer yet, so we need to take care of that. I want to build the dictionary first. So let's build the dictionary, and then we'll move on to building the tags, and we'll see if that works. Okay. Data. Here we go. Fix that. Sample and data. Oh, we're forgetting our colons, you guys. We're forgetting our colons. Okay. Expected else after if. For, okay. So this is a problem here. That won't work. There we go. Okay. We're at, see, little bits at a time, little bits at a time. All right. Now we need to remove this logic because that's not a problem right now. We'll just pass for now. Okay. And boom, there we go. Look at that. All right. Is that what we wanted? Is that what we wanted? Wait, is it increment? Is it increasing? Okay, so we need to delete the dictionary because we had a bug and it kept incrementing the tokens. Novo Digitals, welcome on in. Thank you for subscribing. Happy to have you here. Happy Thursday. You joined the right channel for software engineering. What we built here is AI. We're doing Pytorch and we're learning to become experts in it right now. That's what we're doing. My PC can't even handle 4K. I'm not going to try 32K. 32K is a lot. You should add a text-to-speech for the super chats. Oh, yeah! Loons, good idea. We should add some TTS for those super chats. So that way it plays it like when you donated right now, when you did the super chat, it should add text-to-speech. Okay, I know how to do it. We gotta do, where's our dictionaries at? NLLLSTM star. Where's that? Okay, NLLLSTM star. And we'll rebuild the dictionaries. Yeah, there we go. There we go. And now we can rerun it and it will always stay the same. Okay, dictionary built, success. Let's build our tags now, you guys. Build tags. Training data. There we go. And we're going to print our tags. Tags. Like that. Mythos, yeah. It might happen someday. All right, did we get our tags going as well? Did we figure out our tags? Oh, we got a problem. All right, see, this is the part about being an engineer. Int not in lower. Okay, so tag. Tag, hold on. Oh, we did it the wrong way. So it's index. Yeah, okay, so we got to reverse this. Here we go. I always mix those up. It's weird that index is first. I feel like it shouldn't be first. I feel like it shouldn't be. There we go. Hey, although it's odd because that looks weird. So that's incorrect data. Hold on. Wait. Okay. I get it. So we're loading it and we're rebuilding it. The problem is, I don't think this part's working. Right? Let's try that. Okay. Yeah, right there. So see how it's continuously... This is actually weird. I'm expecting it to continue to grow, and it's not. So something's weird. Something's weird. All right, we got a problem, you guys. We got to figure this out. The data that I'm seeing on the screen doesn't make sense. You got the Cupid operating system, Mythos, and Temple OS. That's pretty... those are the far-reachings of the works, you guys. That's how it works. All right, so we got our tags. The only thing is, right now I've got a problem. We need to see here. Okay. Print tags and dictionary. Okay. Let's do our RM. There we go. And then full. Okay. So it's empty. And however, this is very weird, right? It's very weird. This is odd. There's something wrong here. There's something out of place. It's out of place, you guys. Oh. Okay. We do need to do this. Steven, you should have told me earlier. You guys are like, Steven, that's not gonna work. It's not gonna work. You should have said, hey guys, it's not gonna work. I said offset. All right, fine. There you go. There you go. Plus offset. That was the bug right there, you guys. Right there. All right, let's try it again. All right. Are we good now? Are we good now? No. We're not. I'm like, we're good now. We're good. Nope. Still not good. Okay, we're going to figure this out. We got to prepare our data properly. Why is our sample just so weird? Why is that weird? I don't understand. Determiner, noun, verb, oh. Well, no, it should be fine. Oh. I get it. Okay, I see what's going on now. We're updating in a way that's not going to work properly. Right? So we need to do something else. We need to do a set. Like that. Here we go. I think we figured it out, you guys. I think we figured it out. Okay. Plus offset. I really hope that's going to do the trick. I think it might. I think it might. All right, you guys, you ready? All right, let's find out. Did Steven fix it? Did Steven fix it? All right, here. This is going to be a new poll. All right. Did Steven fix it? Did Steven fix it? The offset. All right, let's find out. Let's find out what you guys think. I mean, the answer is usually no. The answer is usually no. I think we did it this time, though. I think we did it. Did we do it, you guys? Did we do it? Did we solve our indexing problem? I think we might have. I think we did. Here we go. RM. Here we go. Here's the moment of truth, you guys. Here's the moment of truth. You guys, it was find out. We did it. There it is. Check it out, you guys. All right. That's what I'm looking for. That's what I'm looking for right there. We did it. Although I want to increase the verb to 1. We did it. We did it, you guys. It took a while. It was this little problem right here. 3 letters. 3 little letters right here, you guys. This was the problem all along right here on this line right here, you guys. Right here. Isn't that crazy? That's crazy. No, YouTube, I won't say hi for the 5th time. Is it giving you that hi button? To click the hi button, loons?